So I'm Swetha, a product manager at Mathworks focused on Simlink products that support AutoSAR. Today I'm here with my colleague Nukul Sehgal, who is a senior application engineer. We are to talk about how do we migrate traditional automotive application compositions as well as components to adaptive services for software-defined vehicles. All right, software-defined vehicles. So while creating this slide, I was thinking we are almost in the era of software-defined vehicles. But being here yesterday and today, I'm realizing that we are thriving to develop multiple standards to develop and produce software-defined vehicles. So automotive industry is embracing service-oriented architectures as a new paradigm to design modern applications for software-defined vehicles. So it is using service-based approach to provide software updates frequently, selectively over the air. All right, so what are the implications to transition towards software-defined vehicles? So the main customer expectation is to have clean and safe mobility to continue to have the same digital experience across the connected devices, right from your smartphones to cars. And that comes with a demand to create technology and innovation to create safe propulsion, clean propulsion, as well as safe autonomous cars while providing secure connectivity. And also it requires huge investment. So all the automotive players have defined their software strategies to create app stores, software features, and also to monetize software-defined vehicle as a big business opportunity in providing software services, subscription plans as well. All right, let's look at the newer architectures as well as the hardware required. So the key enabler here is to adopt high-performance computers as well as central architectures. So it needs to deliver high processing power to create smart features, AIs, while reducing the cost complexity at the same time. So the new vehicle controllers will run on high-performance CPUs and GPUs along with the zonal computers to manage sensors as well as actuators. So which will again run on service-oriented architectures. All right. Let's take a moment and look at the traditional vehicle, which has body control module, powertrain, and so forth. So normally developed in C as well as model-based design as well. In the recent days, we are seeing a huge adoption of software-defined vehicle. Indeed uses service-oriented architectures. And now there are several standards being introduced around that, including AutoSAR Adaptive, ROS, and DDS. And many customers and engineers would like to leverage their knowledge of developing traditional automotive applications to the software-defined vehicle. So they would like to leverage their proven implementations instead of starting from scratch with intellectual properties as well as libraries, and also use that as a baseline for scaling into advanced features. All right, so these are the objectives I have for today to talk about. So first, I'll talk about what are the challenges in converting these legacy applications to SOA applications, and how do we decompose that into services. Then Nukul, my colleague, will go on to talk about how model-based design can help overcome these challenges and migrate towards AutoSAR Adaptive. All right, what are the challenges? So generally, legacy applications are monolithic in nature. And it comprises of various software components as well as compositions. And we generate that as a single executable and deploy it on a microcontroller, which makes it really low agile towards constantly changing requirements. Right. So we'd like to migrate to SOA applications. So here are the challenges. First challenge is breaking down the monolithic architecture into smaller and modular components, and re-architect the existing applications to see how it will fit into SOA design. And the next step is identifying the services and applications that can provide and define the interfaces between them. with this process, it comes with compatibility issues, right? So make sure the existing services is also compatible with the newer services you're going to define, and it also easy to communicate with the other systems within the ecosystem. And then comes the challenge of managing the data. Since the traditional application data are tightly coupled, and it is difficult to extract and manage it furthermore. And then comes the performance and scalability issues, right? So when you change the existing services into a new services, right, and then make sure it can handle the same load as the existing applications, and it can be scaled up or down based on your need. And then the final challenge is cultural challenges. So the engineers or the whole industry is used to developing traditional applications in C, and for the SOA applications, which can be classic to or adaptive, right? So the transition has to change towards adapting new architectures, new development processes, and implementing in C++. So that's a huge cultural challenge we have seen among our customers. Now, how do we decompose these traditional applications? First is identifying a service that make up to a software-defined vehicle. It's a really challenging part for the engineers to do. And then analyze it to decompose into multiple microservices. So those services into a smaller and modular components. And we are working with several customers to help analyze their services as well as decompose that into microservices. The next step is defining services and its interfaces between them. So make sure that it also follows the data formats and the protocols, that specifications which help define the services, and this defined in the Order Adaptive standard. And the next one is define service contracts. That's a new terminology and also a new process being introduced by the Adaptive Platform 2211. So my colleague Nukul will going to explain that in detail. And the last step here is so implement and deploy services, individual services as it on its own, along with its artifacts, including descriptions. Okay, so now we learned about the challenges and we learned about the high level ways to decompose your traditional application into services for Order Adaptive. So the engineers are used to developing the traditional applications, maybe in model-based design, right? So it is easy to have a single platform, single development process for developing the applications related to software-defined vehicles. So be it non-ORDSR or ORDSR Classic or ORDSR Adaptive. So the next part of the presentation is focused on how model-based design can overcome these challenges. So Nukul will going to talk about steps, workflows involved in moving your classic-based applications to Order Adaptive applications, or it can be generic SOA applications as well. Now, Nukul, over to you.
Thank you, Swetha. I'm audible, right? So we'll move next here. Sorry. Yeah. So as Swetha mentioned, the first step when we're moving towards service-oriented architecture is to define how we are analyzing and identifying these services in my architecture. So if you see here, we have the monolithic architecture, and I'm taking one example of highway lane following here, and I'll decompose this, or I can just implement this in a single service a lot. So if it would have been a traditional monolithic application, we will take this, compile this, build this, and put it into a binary, put it into the microcontroller and run it. But when we are moving towards a SOA, we'll try to decompose this further into various different services, identifying the components from this. So what are the principles? Like, how do we identify those services and break that monolithic application into various components? So for that, luckily, adaptive platform software architecture references are there, and they mention some design principles to mention few, we have highlighted here like what we have tried using, like single responsibility principle that mentions one component should be responsible for one of the tasks, interface segregation, that interfaces of these services should be unique, dependency inversion, that there should be like the less dependency between these services, so that whenever we have to update them, we do not have to update the rest of the services, and a cyclic dependency principle to identify the building blocks, which makes easier for building, testing our service oriented architecture. So, with that principle, we have taken the same legacy model and try to identify the components which are making this right now as a monolithic application, and which can help us break this into various services and build an SOA architecture out of it. With this, we have identified like app services like lane guidance app, detections app, radar service or camera service, and we have tried to show you here how they are mapping to the legacy model. And once these are identified, we can design them using model based design and deploy it into the services which are executable in it individually. Now, to show you how it looks like in actual practice, so I am trying to make starting from the scratch clean canvas, putting some service components here like lane guidance app, detections app, camera and radar service I will add into this, and I have tried connecting them using some of the interfaces, connecting the ports between these identified service components. And further down, we will try to define the service interfaces which will map onto the ports of these service components that we have shown you in previous slides. So, what are the service interfaces? So, service interfaces is a crucial or important element of defining the service boundaries, which tells you how these services are interacting with each other or to the external world. So, here if you see, we have tried defining some interfaces, and we have defined some methods into it, and then we have mapped them to the ports, so that there can be interfaces between these services to interact with each other. Now, talking about the boundaries, if we go further, the boundaries is one of the crucial aspects of service oriented architecture, which actually tells you how the functionality is getting encapsulated. So, that again how we have seen in the principles in the slides before, how it is encapsulating one service with one task, so that it is not dependent on other services, how they are interacting with other services in my architecture. So, these are the service boundaries. Oh, I think it is moving on its own, I am not sure why. I will go back. Yeah. Can you just, sorry, my bad. Yeah. So, if you see here, we are trying to identify, okay, this is again, yeah, here. What we are trying to explain here is some of the aspect of the service boundaries can be a non-functional properties. In model based design context, what we are trying to do is map those non-functional properties to the stereotypes, and the stereotyping contains some property fields which can be once mapped to each of these service components, can be add some data for each of these components, and then you can use them for the analysis purpose later on. Then we come on to the service contracts, and we can see, okay, so to explain you further, first of all, how these service contracts looks like. The service contracts actually explain about how the service provider is being defined, and how the service consumer is consuming the services, what's inside the particular services, and for that we are here showing you in each of these service components how does this are going to be defined using model based design. And then what Swetha has mentioned, that how we are going to analyze the how do we going to ensure the compatibility, the performance related things. We can see how they are interacting with each other. So, how these services components are interacting with each other. Then we can move on to implementation and deployment of these services. So, for that we are mapping the service oriented architecture to an adaptive AutoSAR platform, and for that the methods interfaces that we have defined here, we are actually going to map with the AutoSAR properties and fields. So, we will open these models and we'll configure these for the AutoSAR service interfaces, and we'll use those service interfaces to define the ports. So, here you see the code mappings, we have the interfaces that we have defined earlier, and we can see those service interfaces here, and then the ports that are defined above. Yeah. So, these are service interfaces, and then on the top of it you can see we have the ports defined. Now, this can be mapped to the ports that we are using in our model based design, and then we can choose which component we are interested in to deploy further, and configure the properties related to the XMLs. And once we are okay with the settings that we have, we can move next towards the deployment, where we are generating the C++ code, particularly the C++ code for production intent of this adaptive AutoSAR. So, here I have selected one of my components, and if you see, we are ready with the code, and we will just show you the code side by side. Yeah. So, here we got the C++ code that is generated for this particular service component. So, during the conference, when we have interacted with other people, we have seen there is interest, a lot of interest in the code generation aspects and C++ code generation for adaptive AutoSAR. So, here we are where you can see typically the model based design engineers can work on the core engineering aspect, and again the code generation for adaptive AutoSAR also can help you moving further in your project while generating the code, C++ code, RS stuff for validation purposes, and along with the manifest files which are required for execution, specifying machine properties where your service will be running, and the service interfaces manifest. With this we come to an end, and what key takeaways we want to take you is that there are challenges of obviously to move from a legacy traditional application to an service oriented architecture. Model based design can help you decomposing those in a easier way, just like the principle that was mentioned in the AutoSAR standard, and you can leverage the model based design for overcoming these challenges, the cultural challenges where you have to train your people who are working on this feature implementation for the C++ code generation. They can just use the model based design as it is, and then this code generation can help them deploy those functionalities for AutoSAR adaptive, and then we can come to an end with this.